All right, let's start working through this. So this is using our expanding that we did yesterday, where we had some steps to follow. Where our very first thing we're going to do is we're going to take any division we see and turn it into subtraction. So our first step is that division becomes subtraction. So the first thing I'm going to do is to take this fraction and split it up into two pieces. So we're going to have log base 3 of the numerator, x to the 4th, y squared, minus log base 3 of the denominator, w. So our first step is that division becomes subtraction. Our second step is that multiplication becomes addition. So in here where I have x to the 4th times y squared, we need to switch that to be addition. So we should have log base 3 of x to the 4th plus log base 3 of y squared minus log base 3 of w. And then our last step is that our powers come down and our coefficients. So my 4 comes down in front and my 2 comes down in front. So we're going to wind up with 4 log base 3 of x plus 2 log base 3 of y minus log base 3 of w. And again, it feels like we took a problem and just made it harder, but I promise we didn't. When we get around into our solving stuff, we'll start to see why we need these. Any questions on this bell work one? Okay. So yesterday and in this bell work, we took it and took a single log and made it really, really long. Today what I'm going to do is I'm going to give you big ones like this, and we're going to work our way backwards to make a single log. That process is called condensing, which is exactly backwards of what we just did. So we are going to take things that have been expanded out, and we're going to put them back down to a single log. When we are done condensing, like we know we're done when we only have one log left. So we, again, are going to have some steps to follow. We're using those same properties that we wrote down yesterday. But we're going to put things back into our different orders. Since we're doing everything backwards, we're going to start from the bottom of our expanding list and go back up. So anything we have that's a coefficient becomes a power. Coefficients become powers. There we go. I'm good at tenses. So coefficients become powers is our first step. Then any addition we see becomes multiplication. Myself so hard. Oh my gosh, that hurt. Ooh. All right, so addition becomes multiplication. And then our last step is that our division, or our subtraction, is going to become division. So subtraction becomes division. Go. Okay, so these are the steps we're going to follow, but we're going to be doing the exact same things as yesterday. We're just going to go the other direction from what we did yesterday. So that means when I put them up on the screen, they're going to be a little bit long. Oh, I have to do this real quick. But that's okay. We got this. All right. So here's our first one, and then I'm going to put another one on the right, but I took one away because we hadn't talked about it yet. So the left one, we have 2 log of x and 7 log of y. It doesn't have a base. We'll talk about what it means when it doesn't have a base in a little bit, but I wanted just to practice this a little bit. Base 2 of x minus 5 log base 2 of w. There we go. So our first step when we're working with this is that our coefficients are going to go up and become powers. So my very first step is to take these numbers in front and put them up as exponents. So we're going to rewrite this as log of x squared plus log of y to the 7th. So we took our coefficients and made them powers. Coefficients become powers. Then our next step is to take any addition, and that means we're going to multiply our 2 arguments. So this is going to become log of x squared times y to the 7th. The whole point is to get rid of logs. I want to get down to just 1 log, period. So since we've gotten this down to 1 log, and there's no coefficients in front of it, this is what we call fully condensed. There's no more subtraction. There's no more addition. There's no more other operations in the middle. So we're going to do the same kind of thing on the right-hand one. We've got 6 log base 2 of z plus 4 log base 2 of x minus 5 log base 2 of w. So our first step, our coefficients become powers. So that's not a pen. Every number in front of a log goes up to become an exponent. So the 6 goes up, the 4 goes up, and the 5 goes up. So this is going to become log base 2 of z to the 6th plus log base 2 of x to the 4th minus log base 2 of w to the 5th. So our first step is that our exponents become power, or our multipliers become exponents. Coefficients become exponents. Then we're going to take any addition and make it subtraction. So I see a plus right here, addition becomes multiplication. It's early and my brain is stuck. Addition is going to become multiplication. So every place I see a plus means I'm going to take these two arguments and multiply them together. So we're going to have log base 2 of z to the 6th x to the 4th. And then we have our minus log base 2 w to the 5th. So we took our addition and we made it multiplication. Our last step up here is to take our subtraction and make it division. So we're going to have log base 2 of a fraction. The left-hand side goes on the top. That's my numerator. Z to the 6th, x to the 4th, and my denominator is what's on the right. W to the 5th. Whatever has that negative is what's in my denominator. I'm down to a single logarithm. There's nothing in front. Nothing crazy going on. So this is fully condensed. We don't have any other operations. We don't have anything going on. When we are fully condensed, we have 1 log. That is the worst pen ever. 1 log. That's our goal. When we're trying to condense, I only want to write the word log 1 time. If you are writing log more than 1 time, you are not fully condensed. That is our goal when we condense, is 1 log. And we're going to practice this a bunch of times today. What's up? Yeah, I'm going to your best. All right, let's look at the next couple that we've got here. And remember, as we work them, they're only going to get smaller, so it's okay that they're a little bit long up here. So our first one we have is this log base 7 of 3 minus 2 log base 7 of 4 plus log base 7 of 5. So our first step, anything that is a coefficient goes up and becomes a power. So we're going to have log base 7 of 3 minus log base 7 of 4 squared plus log base 7 of 5. So we took our multipliers, or our coefficients, and made them powers. Then we have to do our addition becomes multiplication. I keep trying to say addition becomes subtraction. Oh my gosh. Our addition becomes multiplication. And this is one that we'll see a lot of times online, in like online versions of the textbook and stuff, because they're trying to trick you here. Because which two arguments are we going to multiply? Which two pieces are positive? The 3 and the 5 are positive. This one's our minus, so we're going to deal with him when we get to our division stuff. So I need to combine together the 3 and the 5 because those are the pieces that are positive. They have the plus. That's where my addition comes in. So this is going to become log base 7 of 3 times 5 minus log base 7 of 4 squared. So be really, really careful if you have a subtraction in the middle, including addition afterwards. Because there's a difference between this one and this one over here that has a very similar but very different solution set. So our last step is to take our subtraction and make it division. So we're going to have log base 7 of my 3 times 5 on the top and my 4 squared on the bottom. And technically we've condensed the log, but we can actually simplify this a little bit because it's just numbers in here. What is 3 times 5? 15. What is 4 squared? 15 over 16. So this whole statement up here is the exact same thing as log base 7 of 15/16, which is gross. And the reason we had to be able to take these and expand them out like this is way back in the day before calculators were invented, they had to actually look up logs in books like a dictionary. There was like an actual book that had tables of values for logarithms because the calculations on them are so gross that they made a reference book out of it. So we are down to 1 logarithm. We are fully simplified. We don't have anything else outside of there. That is our full condensed answer. All right, our next one. This one is fixing that whole which one do we add, subtract, or multiply issue we had over here. Because this one we had our minus in the middle. Here we're subtracting a whole chunk. So I'm still going to start the same way. I'm still going to start with my coefficients becoming powers. And I have a couple of them. Yes, ma'am.
Does that say log base 5?
That is correct. That's 5. I will change the view so we can actually see that better because it's super skinny and I don't know why. There we go. Yeah, it's log base 5 of x plus 2 log base 5 of y minus the quantity 2 log base 5 of x plus log base 5 of y. So I'm going to have log base 5 of x plus log base 5 of y squared minus the quantity of log base 5 of x squared plus log base 5 of y. So we did our exponents, or our multipliers become exponents. Our coefficients become exponents. The next thing we're going to do is we're going to do our addition becomes multiplication, and we have 2 sets of it here. So we're going to have log base 5 of x times y squared. And then we're still subtracting our log base 5 of x squared y. So we did our coefficients become powers. We did our addition becomes multiplication. Now we're going to do our subtraction becomes division. So we're down here to just 1 log. That's our goal, is to get to 1 log. We're going to have x, y squared over x squared y. And when we're looking at simplifying stuff like we did over here, if it's numbers, we can simplify, but we're not going to cross things out because it makes rules be like weird on stuff. So we're not going to cancel out variables. Only if it's numbers can we do canceling and simplifying. So we're just going to leave that like that. Questions on these ones? Okay, we're going to do a mix of both. We're going to do a little bit of expanding, a little bit of condensing, just a little bit more to go back through these one more time. So we're going to come in here and we're just going to look at one at a time. We're going to expand log base 4 of 16x z cubed. So we're going to do both, expanding and condensing. When we are expanding, that's when we start with any division becoming subtraction, which we don't actually have any division becoming subtraction here, so we're ready to rock and roll. We're going to take every place we have multiplication, and we're going to switch that into addition. So we're going to have log base 4 of 16 plus log base 4 of x plus log base 4 of z cubed. Then we need to take our powers and bring them down. We only have one exponent here. We only have one power. So the only one we've got to do. So we're going to rewrite the whole thing just for that one guy. So we're going to have log base 4 of 16 plus log base 4 of x plus 3 log base 4 of z. That's our fully expanded answer. So we're taking it and breaking it apart into pieces. If you want to check your work, what you can do is you can then follow this and do some more condensing and see if you get back to what we started with. So our next one, we're going to do another expanding. Then we'll go do a couple condensing, and then I'll give you the rest of the time to work. So we're going to expand on the right-hand side, log base 5 of 3x over 2y squared. What's up? On the new one or on the old one? The new one, yeah. I was just giving everybody time to walk, or time to write. Yeah, so log base 5 of 3x over 2y squared. What are we going to do first? Yeah, we're going to change the division into subtraction. Division first. So we're going to wind up with log base 5 of 3x minus log base 5 of 2y squared. What do we do next? Yeah. Any place we have multiplication becomes addition. Since I have a multiplication after a minus sign, I'm going to put parentheses. Because this is going to turn into a very long piece right here. Log base 5 of 3 plus log base 5 of x minus log base 5 of 2 plus log base 5 of y squared. Whew. And we still have one more time to go. Because I have two things I need to do in here. What are the two things I need to do to finish simplifying this and expanding it out? The power is going to come down. What else do I need to do to finish this? What do I need to do with this minus sign? Distribute it. So at the same time, we're going to distribute this minus sign through, just because I don't want to have to write it a whole nother time just for that. So the beginning part stays the same. These guys aren't changing. We're going to have our log base 5 of 3 plus log base 5 of x. And we're going to have minus log base 5 of 2 minus 2 log base 5 of y. When we finish expanding, we should have no parentheses and only single pieces after each logarithm. So log base 5 of 3, log base 5 of x, log base 5 of 2, log base 5 of y. It's been 24 hours since we did a whole lot of expanding, so questions on these ones? Now that we've worked with these for a little bit longer? Okay, we're going to do 2 more condensing and then we're done for the day. And I'll zoom them in. So here's our first one. And there's a typo. That should be log base 9. We can only do condensing when they match. So this is log base 9. It's just a typo. There we go. I have a lot in this one. I have so many typos in here. So our first step when we're condensing is to do what? What are we going to do first here? The coefficients become powers. So my 2 is going to go up and my 4 is going to go up. So this is going to become log base 9 of y squared plus log base 9 of z to the 4th minus log base 9 of x. Sorry, I forgot that I had to zoomed in on mine. Then what are we going to do? going to be next? We're going to do the addition next. So we're going to wind up with log base 9 of y squared z to the 4th. And we still have this minus log base 9 of x. Our last step, we're going to take our subtraction and make it division. So we're going to wind up with one single log. That's the whole point of this, is to wind up with one single solitary log. Log base 9 of the fraction. This is my numerator, y squared z to the 4th. And we can see y, I put cross bars on my z's because that guy totally looked like a 2. X. And that is our fully condensed answer. One last one. I'll zoom it in so we can see it. And it's just numbers, so we're going to be able to simplify this one a lot. So same steps. Our first step always has to be to take our coefficients and put them back up as exponents. So my very, very first step is always going to take any number in front and we're going to put it up as a power. So we're going to have log base 2 of 50 squared minus the quantity log base 2 of 5 squared plus log base 2 of 3 squared. Lots of squares. So then we're going to do our addition becomes multiplication. It's in parentheses, so these are our two pieces we're adding together. So this log base 2 of 50 squared is just going to chill. Log base 2 of 5 squared times 3 squared. Then we need to do our subtraction into division. So we're going to wind up with our log base 2 of the fraction 50 squared over 5 squared times 3 squared. Which technically that is condensed. But since these are just numbers, we can actually simplify this. And we can do those squares. 50 squared, we can do that. We have calculators. Gives us 2,500. 5 squared is 25. 3 squared is 9. 25 times 9 gives us 225. And then we can simplify this. You can either put it into your calculator using that fraction button to where we have second column, third button down, and it'll simplify it for us. Or we can notice both of those are divisible by 25 because they have 25s in them. So this becomes log base 2 of 100 over 9. Pretty obnoxious and kind of gross, but it's a thing. And that's our fully simplified answer. Okay, so condensing and expanding are like inverses of each other. They're very similar vibe like that. So you can now work on the whole front from homework 8-2, which is the one I gave you yesterday. On Monday, we'll go through what's on the back, which is where we start to solve stuff. Where we're going to be taking it and condensing it and using our definition of logarithms to solve stuff. Okay, so you guys have a little more than 5 minutes to finish this up so you can work on stuff. Today is the last day for the challenge problem. If you want a cookie, you got to give it to me directly because cookies are going home with me over the weekend. There will be no cookies come Monday.